Hi students, now in this video lecture we will be going through numericals on elevation in boiling point and depression in freezing point. Right, so these are the formulas that we have already done in our previous lectures while studying these topics. So the elevation in boiling point is denoted by delta TB and is directly proportional to molality, and we know molality is number of moles of solute per kilogram of solvent, and if it's calculated out using moles of solute upon total moles in the solvent, right, it would be this, right? So from here we can, using this elevation in boiling point, we can calculate the molecular weight of the solute that is added and that caused that elevation in boiling point, right? So this is the relationship between molecular weight and elevation in boiling point, molecular weight of solute, right? So this is a second relation. This is for this is LV is latent heat of vaporization, right? Enthalpy of vaporization, right? These are also formula that you need to remember. And TB is for boiling point, right? This is for boiling point, and R is for gas constant, right? And similarly, depression in freezing point, we have similar formulas, right? Instead of KB we have KF, delta TB we have delta TF, right? Similar relation between molecular weight and depression in freezing point, right? These are the similar formula. Similar formula like this we have here, depression in freezing point, right, where delta fusion H is enthalpy of fusion, enthalpy of vaporization, right? So most important formula is this one, right, first one, and this one, where we have derived the relationship between molecular weight and depression in freezing point and elevation in boiling point, right? And delta TB and delta TF both are directly proportional to molality of the solute, right? So these are important, and we would be doing numericals based on these formulas. So the first numerical is wherein the boiling point of pure water is 373, right? Calculate the boiling point of an aqueous solution containing 18 gram of sucrose in 10 gram of water. So it's what it's trying to tell you is, we have already understood that when you add solute to a solvent or to a solution, let's say we have added sucrose, which is a solute, to water, it will cause the boiling point of water to rise, right, which is known as elevation in boiling point. So here it says to calculate that elevation in boiling point when 18 gram of sucrose, whose molecular weight is 180, is added to 10 gram of water, right? So if you look at this here, this would be the formula that we would be using, right? And here we know that delta TB is equals to KBM. So when we will when we calculate molality, it would be this 1000 W2 upon W1 M2. So here we need to find the value of delta TB, right? W2 and W1. W2 is weight of solute, W1 is weight of solvent, which is water, and M2 is molecular weight of solute. So molecular weight of solute is 180, right? And weight of solute is 18 gram W2, right? We will convert it to kilograms, right? And KB, this constant value, this constant is given to be 0.52, right? Since this is in kilograms, so we will convert the others also into kilograms. So weight is 18 gram, weight of solvent is 18 gram, we will convert it to kilograms, right? And all this, and weight of solvent is 100. I'm sorry, it was not 10, it's 100, right? So we can convert it into kilograms, it will be 0.1 gram. So putting all the values in this formula, you will get the elevation in boiling point, which is delta TB, right? So it's asking us the boiling point of pure water is this. Calculate the boiling point of an aqueous solution. So boiling point of aqueous solution would be more than this, because boiling point of pure water is 373. So when you added sucrose to it, right, 18 gram of sucrose to pure water, the boiling point will rise, right? Since elevation, the boiling point that was raised, the raised was delta TB, right? So original was 373, so final boiling point would be 373 plus delta TB, right, which would be this much, right? It's 3, right? And this increased temperature, which is delta TB, it calculated out to be 0.52 Kelvin, and this temperature is very low, right? It's very low, so this low temperature cannot be detected by ordinary thermometers. So usually some other sensitive thermometers are used to detect this small low temperature. That is sensitive thermometers like Beckman thermometers are used to detect this low temperature, right? Now let's see the second numerical. 0.70 gram of organic compound when dissolved in 32 gram of acetone. Acetone is solvent. Here this organic compound is solute. So 0.70 gram of solute, that is W2, right, is dissolved in 32 gram of solvent of acetone, produces an elevation of boiling point, elevation of 0.25 in boiling point. Calculate the molecular mass of organic compound. So here elevation is 0.25, that is delta TB, right? And this is W2, this is weight of solvent, which is W1 in this relation, right? And we have the value of Kb for acetone is this, right? And molecular weight we need to calculate. It says to calculate the molecular weight of organic compound, right, which we can easily calculate. And W1 and W2 is given. So substituting all these values here, W2 is 0.70, W1 is 32 grams, M2 we have to calculate, delta TB is this, right? So if you put all the values in this formula, this is the molecular weight of organic compound, right? That was added to 32 gram of solvent, and it produces elevation of 0.25 degrees Celsius. Other is freezing point of nitrobenzene. Now this is these two numericals are on depression in freezing point. Freezing point of nitrobenzene is 278.8 kelvins, a 0.25 molar solution of substance, right? Any substance in nitrobenzene has a freezing point of this much. Calculate the depression constant of freezing point, that is, it's asking us to calculate the value of Kf, right? And we know that delta Tf is freezing point of nitrobenzene is this much, right? So when 0.25 molar solution of substance whose molecular weight is 120 is added in nitrobenzene, it has a freezing point is this much. So just look, the depression, the addition of this substance caused the freezing point to go down. Earlier it was 278, then it went down 276. This is your depression in freezing point, right? So if you want to calculate delta Tf, it would be this minus this, right? So this is the depression in freezing point, and 0.25 molar solution means molarity is 0.25, which is this, right? So you know this, delta Tf and molarity is Kf. Calculate the depression constant of nitrobenzene. Kf can be calculated. Kf would be delta Tf upon m, right, which is this. Similarly, the other numerical, let's see, ethylene glycol is used as an antifreeze agent. We have studied this while doing depression in freezing point, that ethylene glycol is used as an antifreeze agent, right, in cold countries, right, because the radiators of the car contain water, and at that low temperature normally water will get freeze. But water normally doesn't get freeze because radiators contain ethylene glycol as a solute, which depresses the freezing point. It lowers down the freezing point, due to which water remains as a liquid. So ethylene glycol is used as an antifreeze agent. Calculate the amount of ethylene glycol to be added to 4 gram of water to prevent it freezing at minus 6 degrees Celsius. If the temperature of the surrounding is minus 6 or the depression is minus 6, then you need to, and 4 gram of water, right, solvent. So how much ethylene glycol you need to add? That is, you have to calculate W2. If you go as per this formula, W2 you need to calculate. So delta Tf is 6, right, and weight of solute is given to be, weight of solute is W2, which we have to calculate, right? And W1 is given is 4 gram, right? 4 gram of water means 4 gram of solvent, which is W1, right, in this formula. So M2 we need to calculate, and W2 weight of solute, right, we need to calculate this, and M2 would be molecular weight of solute, which we can calculate. So M2 is formula of glycol, ethylene glycol is CH2OH whole twice. So from here we can calculate the value of M2 to be 62 grams. So when we substitute all these values in this formula, where the formula is this, delta TF is equals to this formula, right? From here we can calculate the value of M2. So Kf is 1.85 thousand, W2 is weight is 804, right? So M2 we have, W1 we have, Kf we have. So putting all these values, delta TF we have, we need to calculate W2, right? This one, this value, W2, this one. So putting all the values here, we get W2 as 804.3 gram. This much ethylene glycol we need to add to 4 gram of water, right? So you just need to understand and make sure that the units are same, right? So just you can practice some more numericals. Thanks.